next week's gonna be comprehensive. It'll cover everything from day one going forward. What I would recommend studying is like, look at your notes. Hopefully you took some good notes in this class. I've got a question guide that's in the ABIM library. What I like to do is I like to pick maybe 5 questions or so from most of the areas that we've covered. So for example, maybe 5 questions on riveting or rivets, another 5 questions on materials, another 5 questions will cover bend allowance, another 5 questions that will cover, oh, you name it. Every different particular topic I think is kind of worthy of maybe a few questions. I won't spend the entire exam covering one specific area because we covered so much in the class. So I would kind of look at the major areas that we kind of studied, look at the syllabus, look at the question guide, and kind of use that as a kind of a tool for studying purposes. If you're in the lab, you're also going to get a lab final. The lab final is just like what John Hickman is going to do for the cabin atmosphere class. I usually have maybe 10 to 15 questions or so. They're short answer essay questions that kind of cover the things that you should have learned by going through the shop and doing the projects in the lab. They're not going to be FAA test questions generally. They're going to be practical questions involving things that you had to do. You had to figure out rivet diameter. You had to kind of learn the rules of the road and handling sheet metal equipment, how to buck, how to install rivets, that sort of thing, drill. So those are the kind of things that I would be kind of looking for. So, but that's kind of what I would expect you to do. Let's go from the very beginning and just take a look at a few things that are kind of important. How do aircraft aluminum alloys generally get their strength? Can anybody just give me one word or a couple of words to tell me how? Heat treatment. Very good. What's the purpose of deburring metal prior to riveting? Why do we do that?
Stress risers.
Prevent stress risers. Very good. Why is aluminum never ground on a grinding wheel?
Then it explodes.
It'll cause the wheel to rupture, explode. There are a couple of different theories as to why, but nevertheless the wheel clogs with material and it either balances the wheel or causes so much expansion that it explodes. What kind of joints are ribs designed to take? Shear loads. What kind of joints are made with rivets? Nut joints. What's the purpose of a joggle joint? Okay, so you can see what it does when it's used in external surfaces. It's also used internally. So if you've got like a bolt angled stringer, it's a double bend that allows for the metal to kind of cover it. How are rivet diameters sized? What increments?
30 seconds.
30 seconds of an inch. Very good. The universal head rivet has what number assigned to it? 470. How about the 100-degree countersunk?
426.
26. How are rivet lengths or how are countersunk rivet lengths measured? Would it be overall length or from under the head to the bottom of the shank? Okay. You know the different alloys of rivets. I guarantee on the test you're going to get to know alloys and their markings for the head markings. You need to know that. What's the head marking for the AD rivet? What's the head marking for a B rivet?
Double dash. That's a D rivet.
Race cross. What's the head marking for a DD rivet? What alloy is that? Is aluminum. 20, 24. Which rivets are generally considered to be icebox rivets?
The D.
D and the D. What's the purpose of heat treating those particular icebox rivets? Why are you heat treating them?
For an extra.
to make them soft enough to
Oh,
dry. Heat treatment includes annealing, and that's what you're doing when you're doing that to those rivets. So heat treating it, making it soft in that case. When you put them in refrigeration, it suppresses H hardening. So the idea behind it. Those icebox rivets. D-rivet. Know a little bit about rivets. This is kind of important too. Before you drive a rivet, you should have a projection of 1.5 rivet diameters, right?
Yes.
And after the rivet is driven, what should the rivet look like for the shop head?
Half the day.
It should look like that. Very commonly, I ask people in the shop when they give me a project what the proper shop head dimension should be. They get this strange look, you know? So if you've got a number 3 rivet, a 3/32 diameter, what you're looking for is half the 3/32 diameter for the height of that shop head. So that would be 3/64. How wide should it be? It should be 9/64 in width. So what I'm trying to find out is if you can apply the rule. You know, anybody can memorize the rule of what the shop head dimensions are, but being able to apply it to a specific rivet is a different story. Why is riveting generally stronger than bolting? That's right, it swells to fill the hole. In addition to it, what are you doing to that rivet material when you're driving it? You're cold working the rivet. So you're compacting the rivet material into a smaller space. You all know how to find rivet diameter? Take 3 times the thickness of the thicker skin. Get some samples of how it's done. We've talked about how that works. What else do you need to know? You have to have a minimum of a 1.5 rivet diameter as a projection of the rivet shank in order to get the proper shop head. Rivet cutters, different styles of them. You know the rules of the road regarding spacing. When we talk about edge distance, it's from the center of the rivet hole to the nearest edge of the sheet. When we talk about rivet pitch or rivet spacing, it's from rivet to rivet in the same row. When we talk about the term transverse pitch, transverse means the distance from adjacent rows measured center to center. What we mean by transverse. If I ask you the general rules for minimum edge distance, what's minimum edge distance for rivets? 2 rivet diameters. What's minimum rivet pitch? 3 rivet diameters. Now, there's some variations based on whether or not it's a countersunk rivet or protruding head, but if you can remember 2D and 3D, you're in pretty good shape. Why is that so important? Why the spacing? Why is it important to have no less than 3 rivet diameters between the rivets?
So you're not cutting it?
You're removing too much of the material itself in order to install them. This also explains the reason why you have to be careful when you're working with minimum pitch and edge distance. If you blow the hole out, you really can't do anything because you're too close to the edge of the material or between rivets to install the next nominal size. So you have to be very careful when you're doing layouts where you've got minimum edge distance and pitch for an existing rivet. Okay. There's an FAA test question that you may see that looks kind of like this. And they've had different iterations of this question through the years, and they've gone back and forth, but they finally have got some information that they put in the new airframe book that will help you solve the problem. They're telling you in your new airframe book the smallest allowable transverse pitch is 2.5 rivet diameters. So what they're trying to do in the question, they're trying to figure out how much of a space you have between rivet rows if in fact you're using 2.5D for the transverse. It says a single lap sheet splice is to be used in a repair for damage of aluminum skin. If a double row of 1/8 inch rivets is used, the minimum allowable overlap will be. So what they're talking about is something like this. You got two pieces of metal, and this would be one rivet, this would be the next row of rivets. So from here to here, this really reflects maybe 2 rivet diameters, that extends out from the edge of the material. So this would be 2D. And then from here to here, this represents 2D. And the distance between them represents 2.5D, 2.5D. So if you add this up, you've got 2D plus 2.5D plus another 2D, that's 6.5D. And if the diameter is 1/8 of an inch, you take 1/8 of an inch times 6.5, and it works out to 13/16 of an inch. So that's how they solve the problem. But this is a relatively new rule. Prior to this prior to this information that was in the book, there was nothing that was in the 4313 or any place else that gave you guidance on what they wanted. As a matter of fact, it was somewhat contradictory. This was the info from the 4313. Okay. Layout is important. It helps to avoid things like that. So again, you should know what 2D and 3D is based on differing rivets. Just like you should be able to apply the size of the shop bit for different diameters rivets. You should know what 2 or 3 times each of the common diameters is. And this is I've got a couple of problems where I kind of show you a little bit about rivet spacing, but there's only one FAA test question that you'll have to figure out. And I think I covered this in class. They want you to figure out how many rivets are used in a plate that measures 10 by 5. And you've got rivets that are spaced all the way around the perimeter using 4D pitch and 2D edge distance. And there's really no easy way to solve the problem. The only thing that I could do to kind of figure out what was going on was to kind of draw the thing out. So here's the aluminum plate. To make things kind of easy, I converted all the dimensions into 32nds of an inch and just subtracted out the edge distance rivets. And then what was left over, I divided by that in order to give me the rivets that are in the row. But there's no real easy way to kind of solve for the problem. But you can do it on paper, and I think you end up with 56 rivets or so in the 56 for the 10 by 5 plate. Okay. Okay. Anything else? Lab safety. Your first rivet project. How large should the hole be when you're installing rivets compared to the rivet shank? How much larger is that number 40 drill hole compared with a 3/32 rivet diameter?
2 to 300?
2 to 300s or 2 to 3,000s?
2 to 3,000.
2 to 3,000s, yeah. The consequence of center punching too hard or not hard enough, either the drill will skate away or you'll mark the material so that the drill will also skate away sometimes too. Deep burying holes, use a large diameter drill. Drill stops, usually color coded just like the Clecos are. There's a few FAA test questions that are based on this. You should know that the harder the material, the wider the included angle on the drill. So for example, if you're drilling something like soft aluminum, you've got a very sharp included angle on the drill. The cutting lip angle is half of it, it's about 45 degrees. But in the shop, what we use an included angle of 118 or so. That's used for things like 2024 T3, or a lot of the plain carbon steels. If you're dealing with stainless steel, again, you've got a real broad point. Okay, so the harder the material, the more the included angle increases on the drill. The consequence of clearance too small or clearance too large. If the clearance is too small, the sheets are going to buckle when you drive the rivet. If the clearance is too big, you're going to have separation between the sheets. Rule of 7 for selecting drills. What size drill is used with an 1/8" diameter rivet? Number 30 drill. How about for a number 5 rivet?
537.
Anybody?
Number 2 drill.
Number 2.
20 or 21? Okay. So again, rule of 7. 3 plus 4 is 7, 4 plus 3 is 7, 5 plus 2 is 7, 6 plus 1 is 7. Alternates, sometimes they'll use either a 20 or a 10 to substitute for a 21 or an 11. Cleco, black color code, what size hole? Black. Black colored Cleco.
20.
536.
Again, you should be able to apply the rule for the shop head dimensions. This is important. When you're driving universal head rivets, that cup, or actually any of the protruding head rivets, the cup has got to be sized to the particular rivet that you're driving. If you were to look at the profile of the rivet cup for driving a universal head rivet, the radius of the rivet gun set is slightly larger than the radius of the rivet head. It allows you to kind of cold work the head and hopefully get it centered. If you are off a little bit and holding it a little bit cockeyed, it doesn't make too much of a difference. But again, that's the idea by having a slightly different radius on the rivet gun set compared with the rivet head. So. This is the answer to an FAA test question, okay? The radius of the rivet gun set must be slightly larger than the radius of the rivet head. Okay. It allows for cold working of the rivet head and slight misalignment. Why is tape never used on a mushroom gun set?
We'll pull it out.
Right. It'll cause the rivet to spring out of the hole. Should tape be used on the working surface of a bucking bar?
No.
No, I don't know who's doing that in this shop, but I'm seeing somebody who's doing it. They're using blue masking tape or painter's tape on the surface of the bucking bar. Whoever that is, don't do that. Rule of thumb for selecting bucking bars. The bar should generally
1 pound.
be 2 pounds more than what?
The power of the gun.
Power of the gun. Very good. What's the advantage of squeezing rivets rather than bucking them or driving them?
More damage than two. Uniform shot that anyone damage.
Riveting ears. These are common for people just learning to rivet. This is usually caused by either poor bucking bar control or the shank being too long. And sometimes if a hole is too big for the rivet, it'll cause this to happen. This is caused by a burr between the sheets or a gap. Sometimes if there's debris that hasn't been cleaned out by deburring, you'll end up with what's called a flash rivet. The rivet takes kind of the path of least resistance and it'll swell between the materials. It's called a flash rivet. This is what happens when the hole is too small or you're squeezing and you're using too much pressure and squeezing. It distorts the material. This is called an eyebrow. That's highly objectionable because you damage the skin. It's one thing to smile the head of the rivet. We can always replace that. But if you eyebrow the material, that's a stress riser that it leads to the potential for a crack. So we try to avoid that. Failures, rivet failures. You know what's meant by shear failure? The rivet shank breaks in two. Rivets are designed to take shear loads, but they're also the most common type of failure for rivets. Bearing failure, the holes are elongated. So, you know, you're putting a tension stress on the sheets, but you're pulling the material apart. So that's why the holes are elongated. It's called bearing failure. I asked this on a test tonight. Critical loading. The heads are generally all tipped in one direction. Something else too, you'll see something that looks like this sometimes in aircraft rivets. This is called fretting corrosion. The black streaks that are coming from the heads of the rivets aren't dirt. It isn't dirt. What's happening is the rivet shanks are breaking down and you're looking at the oxide of the aluminum rivet shank that kind of smeared on the surface. This is caused a lot of times by very close fitting parts where the oxides of that rivet shank can't escape freely. So it acts kind of like as an abrasive to cause further breakdown of the shank. These are called fretting or working rivets. And it's really a type of corrosion in a way because the aluminum is oxidizing and it's abrasive in nature. So that's what happens. This is common on helicopters that have vibrational problems where you've got a tail rotor that's out of balance. And the problem is that the vibration is causing the rivets to begin to work or fret. So maybe even on a propeller bulkhead, you'll see sometimes this happening too. The same thing, the propeller is out of balance. What's the most important thing in rivet removal?
Keep the hole
Don't
nice.
damage the hole. How come?
Is it too big for the rivet?
That's right. If you're working again with minimum edge distance and pitch limits, you may not be able to legally install the next size rivet. So you're in trouble. So the idea is not to damage the hole. That's the most important rule in rivet removal. When you're drilling to remove rivets, you drill only to the base of the manufacturer's head to weaken it. If you're lucky, you've got the very center along the rivet shank, and a lot of times the rivet will climb the drill. That's kind of your signal to stop. If it doesn't, you can sometimes twist a little bit on the drill shank, and you'll see that the head will pop right off. Never try to bang the rivet shank through the hole using a center punch. You'll have to use an appropriately sized pin punch, and you have to have lots of support on the backside to avoid denting the material. It's really important. So again, I'll ask you this as part of maybe a test question on the shop file. Okay, most important rule is not to damage the hole. Joggles and sheet metal, a lot of different ways it can be made. This uses a brake method. So you're bending the material one way, then turning it upside down and putting it back in the brake to rebend it, makes a joggle. But in the shop, what we use is a set of joggle rollers that make a nice joggle and spaces them really nicely. and the joggle clip, it bends at like the tines of a fork. So the material goes between the tines and then you just bend it over. The other way to make it joggle is by using dies where the material is pinched between the two of them. The joggle clip. These holes have been what? They've been, anybody? What's that term called? They're flanged.
Plans.
Okay, so what's the idea behind flanging that hole, those holes?
Makes it more rigid.
That's right. The idea is you're cold working the circumference around the hole, so it gives it a little bit more rigidity. Whenever you cut the material away, you're losing some of the rigidity, but you get a little bit of it back by cold working the circumference, and that this is called flanging. Flanging the hole. A lot of different ways that they can be done. Sometimes rollers can be done for it, or die sets can be used to flange it. Sometimes even a block of wood with a slip cut in it, you can just kind of move the material over and just kind of bend it a little bit. These are flanging dies. What determines what method you're going to use for counter or for flush riveting? Thickness of the material. Thin materials are usually dimpled. Thicker materials are usually countersunk, where you're dealt cards in the deck that are combinations of thick and thin. Sometimes you have to subcut countersink. There's a lot of different ways to dimple, and again, I think we covered a lot of them. You can radius dimple, you can draw dimple. There's a lot of different ways you can make a dimple. But again, usually thin materials. Here's a cross section of a rivet in a dimple hole. Different types of dimpling. Is it possible to over dimple a hole? Okay. How would you check for the depth of a dimple?
With another rivet.
Rivet, and what are you looking for?
Flush.
Okay, the rivet head should be flush with the material. Thermodimpling, this is used on materials that have very low formability. This is the gouge to an answer for an FAA test question. If you're, when you're going to be countersinking, obviously you can't countersink into both materials that have been lapped together. The depth of the countersink can go through the top skin, but not into the bottom skin. So it says one factor that permits machine countersinking is that the thickness of the material must be greater than the thickness of the rivet head. So. Microstop countersink cutters, microstop countersinks. I think you know how that works. Subcut countersinking, knacker riveting. Micro shaving, crown flush rivets, bowing rivets, Briles rivets. Some of these things are hard to see. Project 3. Bend allowance. When you're using the formula for bend allowance, what you're trying to do is you're trying to make a part that requires no alteration after you've made it. So it should fit exactly what you've designed it to be. So it says in order to develop a flat layout in the part so that after bending the part will fit without any alteration. That's the idea behind learning or at least applying bend allowance. You need to know a lot of things when you're calculating bend allowance. You need to know the thickness of the material, what type of material it is, and the temper or hardness. Remember also too, when you bend sheet metal, we try to bend 90 degrees of the grain. It's not always possible to do that, but if we can, we try. The idea is you get uniform strength from the bend by doing that. Okay. What's the consequence of using too small of a radius for bending? Okay. Where would it crack?
On the outside.
Outside of the bend, because that's where it's stretched, right? The smallest bend that can be made is referred to as minimum bend radius. There's an open angle bend. The distance between the legs is greater than 90. Closed angle bend, the distance between the legs is less than 90.
So when you're doing the setback and bend allowance calculations, you use the 135 for the closed angle bend, right?
Yeah, that's a good question. If let's take a look at the picture on the left. If you were setting up that problem for bend allowance, would you use 135 or would you use 45 degrees to calculate bend allowance? 45. You always use the number of degrees that the metal has been bent through in order to make the part. So in this, I would be multiplying by 45 degrees for the number of degrees in the bend. On the other hand, to make this particular bend, you had to bend it from flat over 90 to 135 to make it. So you'd be using 135.
Are you gonna have bend radius problems on the final?
You'll have at least one bend allowance problem on the lap final. You'll have to work bend allowance.
On the
May
lap
not be
final?
too complex, but you'll have to work one. The line of sight, where does the line of sight go for bending?
Usually between
One radius from the
Yeah.
inside bend angle.
That's right, one radius from the bent tangent line that's first positioned underneath the brake. It doesn't always fall between the two bent tangent lines. Like a good example of that would be the skins that you're doing for your airfoil. You've got a very small amount of bend allowance, so the bent tangent lines are very close together. The line of sight extends beyond both of them. So it's one radius from the hidden or inside bent tangent line, whichever one goes into the brake first. There's an FAA test question that's based on this information as well. If you have to figure out, if you're looking at two brackets, for example, and they've got different radii, even though they've got the same overall dimension, the one that has the smaller of the two radii, radius is going to give you the overall greater amount of material to make the part. You can kind of rationalize that answer by asking yourself, did you have to push the material into a tighter corner when you were making the part? And if the answer is yes, it's going to require more overall material to make it. So again, whatever has got the smallest radius in the selection of possible answers is going to give you the greatest amount of material required to make the part. Should the developed width of a part be greater or less than the finished dimensions? Less than the finished dimensions. So when you're doing a bend allowance problem, if you come up with an answer for your developed width that's bigger than the finished dimensions, your answer can't be correct. So you have to logically reason for yourself how the answer, what the answer should be. Alloy 2024 T3 is alloyed with what primary alloying element? Copper. Is that heat treatable?
Yes.
Yes. How about alloy 7075?
Yes.
Is that heat treatable?
Yes.
What's the primary alloying element in 7075?
zinc.
Zinc. Notice also, here's inside bend tangent lines. They've got a relief hole at the intersection of the inside bend tangent lines. This will prevent the part from cracking as you bend it. In your rib, you've also got relief holes too at the leading edge, where the two side flanges meet the leading edge flange. You've got relief holes that are drilled there. What is K-factor used for in bend allowance? Bends greater or less than 90 degrees. Is K-factor the same thing as setback? No, it's a modification that we use with setback. Skin layout. Here's a good example. Here's the line of sight is the red line, so it falls outside of both of the bend tangent lines. Shape chart, hand forming, machine forming. This type of bending is useful when you have bends other than straight line bends. If you've got bends that follow a curvature, obviously you can't make that on a brake. You'll have to use some other method of forming. Stretch press. Bench stakes for handwork of aluminum. Wiring and edge. Slip roll former. I want you to look at this picture. Here's an example of using the V block to both shrink and stretch. When you tap on the vertical flange of that bracket, what you're doing is you're shrinking that flange. That causes the material to curve over. On the other hand, if you insert one of the flanges inside of the groove of the V block and then tap in the center, you are stretching that material. Does that make sense? Mm-hmm. Okay. Here's a curved bracket or a curved part. We've got two flanges. One is going to be a concave flange, the other one's going to be convex. The concave flange, that one is going to be stretched. When you bend it over, it's going to be assuming a new position that flattens the metal out and thins it. So technically it's stretching the material. On the other hand, the convex edge of it, when you bend that thing over, is being formed over a smaller circumference of a circle or a smaller arc. So what you're doing in that case, you're actually shrinking the material. So this one is being stretched on this particular flange, and this edge, or it should say this flange, is being shrunk. Streamline cover, duplicating pattern, English wheel. Beading in sheet metal work. These are beads. There's a beaded edge around a circle inside of maybe a rib. Beaded edges here as well. It's a way of cold working when you don't have a lot of internal structure to give you strength. You look at a lot of flaps or ailerons on control surfaces, they're beaded, or at least they got corrugations in the skin. So because there's not a lot of internal structure to give it strength, so it gets it straight through geometry. So they're cold working the material to provide strength. Repairs. Chapter 51 covers standard practice for repairs in aircraft. What's the first step in doing a repair?
That's
Action.
about-
Classify the
Damage.
damage. Here's an example from chapter 51, an assessment manual. They give you some examples of actually classifying damage. Okay, patches. Sheet metal. Damage classification. Why are holes stop drilled? I'm sorry, cracks stop drilled.
Just stop on the property.
You can also see the advantage or the necessity to have radii in any part that's being crafted. You're preventing a stress riser from causing a crack to occur. When you selected rivets, you follow the rule of the road so that you have somewhat less shear strength than the bearing strength of the material. But again, the consequence of having a big fat rivet shank and thin material, this is going to cause bearing failure in the part. On the other hand, if you've got too small of a rivet shank diameter, you're going to end up with premature shear failure of that rivet. So there's kind of a happy compromise. When you use the rule of 3 times the thickness of the thicker material, it sets up that lap joint so that it loads the joint primarily in shear, and it would prefer to have maybe a few rivets shear in 2 and have bearing failure in the part. Shear strength, bearing strength, repair example. Strength. Repairs, surface patches, flush patches. Rivet charts. If you elect not to use the formula, you can use tables that are in the 4313 to figure out rivets per inch. But I prefer to use this for stringer type repairs. There's a 337. Examples of major repairs and major alterations, Appendix A and 43. Special fasteners, pop rivets, explosive rivets, what does the color code denote on those rivets? They're anodized color.
Grip line.
Grips. Different types of blind rivets. When we talk about a blind fastener, what does that mean? Installation from one side only. Cherry Max rivet. What does a silver driving anvil indicate on a Cherry Max rivet? Oversized. This is a high shear pin rivet. I asked you a question about this on the test tonight. If you underdrive that collar, what does that mean?
It's not very full strength.
Yeah, it doesn't refer to anything or mean anything in terms of strength because it's designed to take shear loads. So it doesn't mean too much. When high shear, when Boychan came up with the high lock, they did away with this particular type of fastener. But they're still occasionally found out there. Once in a while, you'll see substitution of this with maybe a close tolerance bolt. But that's about the only thing that I know that will kind of substitute for it. Oh, well, that got me out of that thing.
Computer shutting down.
Shutting down.
That's it, guys.
Somebody must have done that. Okay, we did it. It's about 2:20. Let me pass back your written assignments. If there's no grade on it, it's going to require a little bit of corrections. Since generally it's my correction. So come on, you have your written assignment. Dimensions on this one.
You have no grade or this is your
I'm never gonna get a grade for it now.
It's graded.
What is this? I want to see the formula for figuring out the rivets. and
Oh,
I just
okay.
used the one you had on there.
I-
That's okay, but I want to see if L times T equals 75,000, give me the formula for it. So, there's one on this, this one, which one is this? Yeah, let's see.
For the dimension,
You turn this in tomorrow.
Yes. So we do a 337 form block in.
Huh?
Okay.
your dimension.
The information the mechanic does is on the side.
Hold
Cut out the meter repairs for lights.
No, if you give me that too.
Another section of block eight that's done by the authorized inspector. After the work has been done by the mechanic, the authorized inspector looks at that work and says, the repairs we need to cover.
Ah, there's shit.
Okay, so, and then the mechanic comes back and he writes, covered with polyfiber fabric covering, whatever has been done. This isn't a certification for return to service, this is a certification setting criteria for the data that's been done. Okay?
And then the mechanic comes by.
Finishes off the fabric covering.
Okay.
I just got these two dimensions.
I have one more question. How many questions? Or all?
Inside,
Probably 40 to 50.
Okay.
and what I did was just.
Okay, this one, let's see what I did. I couldn't figure out what you printed directly over on top of the media
I'm not sure why
for
you.
the assignment, but you've got crushed tubing from the cluster wells, which is the image you have for your well is this.
5 8 outside that.
Because
Yeah, so
I think
it's 5 8 plus
You got another cluster
the
well here.
thickness.
Because the thing that he sold here
And you've
is
got
the-
damage in this area.
right
So how are you gonna repair that? What you've got illustrated for your repair,
here.
what you got,
Crap, dude, where is it?
you got damage
I did
that
that.
kind of gloves over this.
Where is this?
I did
Okay,
that.
and that's not what's been damaged. You got materials that damaged between cluster walls. Also too, so you put the.
So Jesse,
It's gonna
yours
be a
is 5/8.
slice.
Where'd you
You're
get
gonna cut
5/8?
this
Well, mine was
material out, you're gonna
3/4.
slice it.
So you want
You're gonna
5/8?
end up with,
You just
scarlet
need
on
5/8
that.
then?
You're gonna
Yours is
scarlet on
longitudinal,
that, and
huh?
you're gonna sleeve it with a piece
Yeah.
of
Yeah,
material.
mine's
Maybe
circumference.
internal sleeve on the
Mine's
side.
different.
That's the repair.
I don't know how to do it.
I mean, I just knew how to do it because
What you're
it's
illustrating
on
is
power.
the finger patch plate, and
Yeah,
it's not
no,
what's
Yeah,
been
but-
damaged.
Yeah,
You've
so
got
this is
material damage between the cluster walls.
vehicle, oh, that was
Also,
it
for your
right
sheet
here.
metal repair,
0.75
a
plus
patch plate.
3.
we don't do this.
But it doesn't tell you,
We do something like this. You've got maybe a doubler that's on the inside of it,
He wants the number.
goes over here,
He wants
where we have the staggered rivets
Got it.
like this.
line.
Does that make sense? For your repair, what you did was you went around the circumference of the hole. I don't understand that.
There's a crack on the launch room.
Did you want to?
That doesn't tell you. Seems
You know what's
circumference.
is that what searching?
I think 11. That's it.
Yeah.
It would look like this in process.
Do you know how long that
Did
is?
you guys try one?
So the class starts.
What you would have is a
I can
doubler
go
on the
right
bottom
after.
side. and then a
That's
cluster.
what I'm saying.
So you would have rivets here and here,
They got
here,
time.
and here.
On my
Okay. So what it would look like from the surface.
Me? Yeah, hold on.
almost like.
Would be the underside of the material. And this would be the cover. If you want.
One,
Free
dimension.
finger inspection.
No
That's
more
all that.
dimensions. I'm not sure why he circled that
Okay.
because
Probably wants this,
he does, he
this,
wants to.
this, 30 degrees.
I did the 30 degrees.
So the question I guess, is I put internal practice. And then it's 2.5 times, to determine that it's 2.5 times the slave, it was,
What's the actual dimension?
the actual dimension.
What's the diameter?
You good?
It's,
Yeah.
outer diameter of
Minus 16. So 2.5 times on 16, right?
yeah.
So why don't you write that in?
Hold on. Did, just print this. I probably just don't specify, very well.
So you can pull back on it tomorrow for make up some time.
Actually,
Paul, what time can we get here at?
Is it 11?
11?
tomorrow,
Yeah.
tomorrow I'm not here in the morning. I'm here, tomorrow is what, Wednesday? I'm here for, I'll be here probably about 3:30 or so in the afternoon.
There, we can show up around 3:30.
Well, if you'd like to, you're welcome to.
I think I
I'll be here at 3:30 as well then, if it's okay, sir.
Yeah, I would like to as well.
Can we still come in early just to work on the airport?
If there's nobody here to supervise you, you won't be able to draw materials or tools.
Oh, okay. But if instructor's around?
If somebody is here, but I guarantee you I won't be here.
Oh, okay.
Tuesday is my day that I'm here for, well, I got here this morning at 5:45 this morning. I will get home at 11 p.m.
Oh, wow.
So I'm not gonna come in.
Can't say I'm like.
I understand.
Okay,
Sounds good.
Oh,
It's my work.
okay, if the outer diameter, because what I did 2.5 times 9 divided by 16 is a 0.56. So it's about an inch and a half.
that's fine. What I'm trying to tell you is you can't use just generic information. You can't use 1.5 D or 3D, or you have to actually have finished dimensions for that thing in inches or fractions of an inch. So you can't use, I don't wanna see things like that.
Oh, okay.
You're gonna have to convert that into actual fractional dimensions. Does that make sense?
Yeah.
Okay.
There you go. We'll just give this back to you then.
Yes, leave it right on the table.
How did I think I did all right on the first one.
If I had no comments on it, I guess you did fine.
There's no comments.
Thank you.
No.